Tutorial we're gonna talk about reversing and flattening arrays. So let's specify an array X that's gonna be 3.4 dimensional array, and we can use the .x or .travel, turn this array from a 3.4 dimensions into a 1 dimension array, meaning a vector of 12 elements. Let's check it out. So the only difference between flatten and ravel is that ravel does not return a copy. What does that mean? Here, if we specify x.ravel equals to a2 and then go and manipulate a2, you can see that the element in x has changed because .ravel returns the position of x array. So this is really important to know, because if you do that, you may manipulate your original array and not knowing that you do not work with a copy. So if you want to keep x unchanged, what you want to be doing is using x.flatten that returns a copy of this array into a new memory position. So by manipulating k1 here, as shown in this example, you do not change the values in x. So let's try it out. Boom, x has not changed. You can also do flipping and reversing of arrays by using the np.flip. So what we can see here is that the array is flipped upside down through the diagonal. You can also specify the flipping operation. You can flip only rows, or you can flip only columns. Finally, you can use the numpy.sort to do sorting of arrays. So you can use numpy.sort and you can have your array sorted. So let's check it out. Boom, your array is sorted here. But bear in mind that np.sort is not an in-place operation. What it does, it returns a copy to a new sorted array. However, array.sort does in-place sorting of the array. So the original array is gonna end up sorted in memory. So just keep this in mind when doing sorting.